Yeah. Bismillah. Good morning, everyone. So, inshallah, we continue our few remaining stuff that we need to cover in the chapter 5. Basically, we finished last time talking about the transconduction GM. What's the GM unit?
1 over ohm.
What's the unit of GM?
1 over ohm.
1 over ohm. What does it remind you about 1 over ohm? Conductivity. Very good. That's why we call it transconductance. So it is a conductance unit. And trans is just basically because it's a transit thing. So output, the input voltage, turns into current in the output. So transconductance. Good. So the equations that we may use for GM are 3 basic equations. So the first one we studied is this one. This one. Okay. GM is equal to Kn times the overdrive. Okay. Which is from where? Which is from, remember, GM, remember, just to remind you, is VGS, the AC signal VGS, over the AC current ID. Remember that? And we found it to be equal to Kn VGS minus VT, which is V overdrive, yes or no? So it has 2 terms only. Kn V overdrive. Boom. That's it. You don't have to make it hard. Clear, easy. Huh? That's it. So that's all what we need to remember. This is what we did last time. That's it. So this is the first equation we need to remember. That's it. So really, we want to play with the equations. So what we did here in this step, we just replaced the term of the overdrive voltage by this equation. Where we get this equation? This equation. And what is this equation? This is the current in saturation. Because the amplifier cannot work in triode. Because it's not a VCC, a voltage controlled current source. It's been a long time, 2 weeks. Wow. We need to take a shower here. Okay? Good. So that's the thing. So the MOSFET can be working as a VCC only if it is a saturation. That's the equation for saturation. Of course, we ignored the channel length modulation. There is no lambda in here to make our life easy. That's it. So the overdrive, you see, is a square root here. So bingo, we take all this on the other side, it becomes this, and then we square root the result. That's it. So this is what? This is the second equation of GM. It's the same. That's it. Why we did this? Because sometimes I'm not interested in this parameter, or I don't have this parameter. I have ID, for example. Okay? So if I have ID, so boom, boom, that's it. I have the other parameters. Same. That's it. When you develop, so this is one, and then what else in here we can do? Okay, that's it. When we develop this equation, we get this equation. We have a square root of 2ID, of 2ID, what's that? Or square root of ID, put it aside. We have W over L here, W over L here. So it will be square root of W over L here. And we have Kn prime. So it will be square root of Kn prime, or 2 actually. There's a 2 there of ID, put it in here. That's it. So this is another equation. Okay, they are all equivalent. We don't need to memorize them really. And we also discussed this. So basically, if we draw the characteristic or the ID versus the overdrive only in what? In saturation, yes or no? We find because it's quadratic relationship, yes or no? Square root? No, it's a power 2. Power 2, so it's a parabolic. So GM in this case will be the slope. The slope, is that right? No, 1 over the slope. 1 over the slope actually. Hey, I think so. Well, hold on a second. The slope here, okay, let's see. Let me remember. So the slope here is actually delta ID over delta the overdrive. Let's see. Delta ID over Let's see. So the slope here, let's see, is different from that. Oh, that one is called ID versus VGS. This is ID versus overdrive. This is totally different. So this is number one. Number two, the slope of this point is equal to what? Is actually, what's that? So the slope of this point is equal to what? Which is the slope of this line. Yes or no? Yeah. And the slope of this line is actually what? Exactly. So is ID, ID, which is this one, divided by how much? Divided by this distance. The distance from this point to this point is half of overdrive. This is like a graphical way, okay? It happens that is actually, that slope happens to be GM actually, is equal to this quantity that we just calculated it. Okay. And if you calculate this, we come here. Let's see. So when we develop this, so it's equal to what? It's equal to 2 ID, yes or no, divided by the overdrive. Yeah. Okay, that's it. So what we do? So GM, 2 ID is here, divided by the overdrive. So this is what? This is the overdrive, yes or no? Square times the overdrive. So it means we have the same equation, yes or no? Sir? Because we can cancel this with square root. Yes or no? Bingo. So it's the same. So we know this because this term is inside ID, yes or no? Yes. Because ID in DC, we have to use the DC. So ID divided by the overdrive square is actually this term, yes or no? Yes or no? But, so that's it. So that's ID divided by this square. So we can say it's half of Kn times what? Times overdrive. We can write that. Half Kn times the overdrive. Hold on a second, there's something not quite right here. Oh, but there's times 2 here. Now, when this times 2, so we get the same GM like we did last time. But the purpose of doing it this way is actually not that way. It's actually to arrive to this same equation, which is 2ID. This is actually, so this is the graphical way, but in here it's not the graphical way. Actually, this is analytical way, in which GM is equal to this Kn prime W over L, which is Kn, V over drive. He get this Kn prime W over L, which is this one. When we develop this one, it will be Kn prime W over L. Okay, so this. Okay, so let's get this. So this is the equation we found so far. Yes or no? What is this really from the equation of ID? So if we write this in terms of Kn prime, so we are using the same thing. So it's half Kn prime W over L. Yes or no? Yes or no? This will develop only this. V over drive square. Yes or no? This is what? This is ID. Yes. Correct? Yes. So this parameter, which is this parameter, is equal to what? Is equal to 2ID divided by overdrive square. Yes or no? Yeah. When we apply it, so it will be what? 2ID divided by V overdrive square. Yes or no? So we take this and put it here. But we still have this one in GM. Yes or no? Yes or no? Yes. Did you get the point? Yes. So this is a graphical way, this is just analytical way. So we come back to this equation. So this, which is equal to this, yes or no? Just a second. So this is this term, but we have the overdrive. Yes or no? Yes. Which is this term. You got it? The overdrive. Now the overdrive with the overdrive square will cancel out. Boom, boom. And we have only the overdrive there. And 2ID on top. Yeah. So this is another equation for GM. Very simple one. 2ID divided by V overdrive. Got it? So in a nutshell, we have three equations, equivalent equations. For GM, we have the very basic one, the one that we know already. We have the second one, which is this equation, and we have this equation. So which one we use?
Depends what we have.
Exactly, it depends on the problem. Yes or no?
What we have.
Exactly, what we have in the problem. Like for example,
If we don't
if we have the overdrive and these parameters, we can use this equation. That means if we don't know the ID and we know the overdrive, we can use this. If we don't know the overdrive, we know the ID, we get this. Okay? If we know both and we don't know the dimension of the transistor, then we get this.
Yes.
Yes.
See? So these equations, they describe the situation in which we can calculate the overdrive. We don't have all the parameters all the time. Sometimes we have some, we don't have the others. Yes or no? So this is the way. Why this is important? Because GM is an important parameter in an amplifier. You can see later, starting today, that GM is a very important parameter. We need to get it at any cost. Meaning, we have to find all the ways to get GM. So, if we know the geometry of the transistor, so either this or this, because we have W over M. If we don't know the geometry, then definitely this will be used. We don't have W over M, صح ولا لا? We don't have it. And things like that. Okay? So, that's it. So this is basically it. If we have time, we'll come back to this example. Shall we do it now or let's see. We'll do it later. Because here we are talking about the amplifier. Let's not talk about it now. We'll do it at the end of the class, okay? Okay? We'll do it at the end of the class if we have time. Because we are a little bit behind in schedule. So, today, we'll start talking about the amplifiers. But before doing the amplifiers, we have to mention something really important. This is an amplifier we're going to study today, inshallah. One of them. Probably today or maybe sometime down the road. In an amplifier, the first thing what we need to do is need what we call the bias. We need to make sure that our transistor is working at an operating point where we have a GM that we need in amplifier. We'll talk about that later. But to do that experimentally, we do it in the lab, we need capacitors. What's the role of these capacitors? Like for example, this amplifier, we have a capacitor at the input and a capacitor at the output. The role of the capacitor actually is to keep the DC voltages applied on the transistor here, basically keep the bias point of this amplifier untouched by the input voltage and the output voltage, or to keep the DC bias of the transistor untouched by the previous stage circuit and the output stage circuit. So we need these capacitors to keep the DC voltage here not disturbed by the input or output, so that the transistor will work at an exact bias point. Okay? So this is a very important thing that we need to take it today. Okay? And when we analyze the transistor, we have to do two analyses. We need to do the DC analysis and then the AC analysis. The DC analysis, what's the benefit of it? So far, what did you study in the amplifier? GM. Okay? GM is an important parameter. Okay? And GM, we get it from the DC analysis, because in DC you have the overdrive and we have the current ID. Yes or no? So we need to find GM. We will find also other parameters that are important. Later on we discuss the input resistance, output resistance, voltage gain, and input gain. But these are not really, they are AC parameters. This, we find them in the AC analysis. But the DC analysis, the first and foremost important thing is the GM. Because GM is the amplification factor. We'll see it starting today, inshallah. Okay? Then once we have done that, then we throw everything there inside. You can see GM here, yes or no? Yeah. Because the current that we're gonna create is actually GM VGS. Yes or no? This is the AC current that we're gonna create. And this is from the DC analysis. GM is from DC analysis. This is an AC signal which is at the input. Okay? That's it. That's the only thing really in this amplifier. Very simple one. So once we do the AC analysis, then we can plug in GM and then we do the AC analysis. We'll study that later on. Don't worry. Okay? But I'm telling you just the overall picture. Okay? Great. We're done with this part. We'll start the new one. Okay? That's why I told you we are a little bit behind because of the break. Okay, let's see. So today, inshallah, we start a new set of sections. Let's see. Okay, let's see. Is this one? No, not this one. No, not this one. Is it this one? Yeah. See here? That's what we need to study today. Yes, exactly. Okay. So we are going to start from here today. Okay, good. All right, great. All right, gentlemen. Good morning again. So today, inshallah, we're going to study a very important thing, which is the biasing. We are talking biasing. We will talk now a real thing in biasing. Okay? And amplification later on. You cannot do an amplifier without biasing. If you don't bias it, it will not work. Okay, good. So, all right. So we said that a MOSFET cannot be an amplifier if it's not in this mode. It's not what? If it's not a VCC. VCC, voltage controlled current source. VCCS. Why? Because it's an amplifier. An amplifier needs an engine to amplify the signal, and that engine happens to be a current source. Okay? And that in this particular case is the MOSFET. Okay. So now, how can we really translate the current output? Because that's what we have as a VCCS, yes? Well, how can we translate the current output into what? Into voltage. Very simple. The current times the resistance, we get the voltage. So no. Yes or no? So the only thing to do it is we have to hook it up with a certain resistance. Let's see that. If you remember that what we did a similar thing in the voltage gain in the previous slides. So let's calculate the output. This is a simple amplifier. We will tell you later on how we call this kind of amplifiers. But this amplifier is composed of this input voltage. What do you see this input voltage? Is it an AC, DC? What type of this voltage?
It's AC.
How did you know that?
The V small.
V small? Okay, this is small.
GS.
But that's not AC.
It's total.
Very good. That means what? That means this guy is providing a DC voltage and an AC voltage. See, the March break is killing our memory, yeah? Good. So yes, it's an instantaneous voltage. That means we have a DC voltage that will bias this transistor to a certain point. Yes or no?
Yeah.
Because if we have VGS, we have overdrive. If we have overdrive, we have GM.
Yeah.
Because GM is equal to what? Very simple. Is Kn V overdrive. Kn overdrive. Two parameters. Sahawala? We just did it today. I know it's we are cranking up the engine. It's gonna take some time to make the engine rotating. Sahawala? Remember that? GM, Remember? It's Kn actually. Sahawala? Kn times V overdrive. We did it, yes or no? Yeah, we have others, but this is the simplest one. I like simple. Simple is good. Yeah. Give me Kn, give me overtime, give me GM. Very good, excellent. So, now we need to calculate the output is actually here. And again, here we have the total voltage. So, VDS happens to be here. So we have VDS that is DC plus VDS that is AC. صح ولا لا?
Yes.
Because that's the thing. Okay, good. Here, VDS is equal to what? This voltage is equal to this voltage minus the drop. صح ولا لا? So it's VDD minus the drop is IDRD. Simple. Okay, the current times RD. Yes, Ali? Hamad? Correct, huh? Nothing really, we are not making it big deal. Good. Alright, let's see. Alright, very good. So, we are going to introduce you to what we call the voltage transfer characteristic of this amplifier that we call it CS. CS stands for common source. We'll talk about that later. That's the name of that amplifier. Don't worry about that for now, okay? Now we have three regions. Because why? Because it depends on VGS. صح ولا لا? If VGS less than VT, if VGS less than VT, what happens? Do we have a current? We don't have any current. If we don't have any current, the output is equal to what?
VDD.
That's it, VDD. Then VDD minus ID blah blah. ID is 0. Boom. That's it. خلاص? We have no current, no business. Now, as we can push VGS a little bit above VT, we get first phase is what? Why? صح, very good. Now VGS now is a bit bigger than VT, but still less than VDS plus VT. Why we are here in saturation? You read it from here, صح ولا لا? Excellent. So why we are in saturation? صح?
The overdrive it reached.
What's that?
It reached overdrive.
What's the condition of saturation, Bilal?
So less than overdrive for this overdrive will be the VT.
First of all, the first condition is that we have a channel. So we have business. VGS is above VT.
Yes.
صح ولا لا? First condition is gone. So our second condition is what?
Less than overdrive.
What is less? What is less? You said less. What's less?
VGS.
VGS less than?
V overdrive.
Who agrees with this guy? What's your Muhammad. Who agrees with Muhammad? You agree with me? What's the condition of saturation? Now the other question that we'll say that the March break has broken our memory in pieces. صح?
When the depletion region is forming.
Then there is a specific equation for saturation. There's no zigzag.
لا لا اللي قلتها التريود مو بالساتوريشن.
So we are talking about انت قلتوا saturation صح ولا لا؟ كيف
Saturation
saturation?
more than overdrive.
What is the
VGS or
I told you memory is gone. Mahmoud, any clue?
I think VGS less than the overdrive.
VGS, huh?
Yeah.
You're still insisting on VGS. صح? VD what?
VDS?
VDS is?
Is it equal to the overdrive?
Huh?
Equal to the
Equal لا?
More. It's more.
Bigger than the overdrive. Remember? Triode and here VDS. With VDS above overdrive, we are in saturation. Remember that? صح ولا لا? I told you guys, we have to revise very hard because the quiz is next class. صح ولا لا? So, refresh. صح. Okay. Now, what's the output actually? V out is equal to what? It's actually VDS. VDS, DC plus the AC. Now, still we are not considering AC. So it's actually VDS. VDS in the cutoff was equal to VDD. Overdrive is less than VDD. صح ولا لا? So as soon as we are above the VT, as soon as VGS is above VT, VDS is still close to VDD. Yes or no? We are here. That's VDS. VDS here. VDS, which has actually the output actually. VDS or see, this is VDS. Is still close to VDD. So still VDS is above overdrive. So VDS is above overdrive and we have a channel. We are in saturation. صح ولا لا? Got it? Very good. So we go to saturation. The amplifier is saturation automatically. Okay? That's why we have these equations. So the overdrive is positive, so we can apply this equation. Hold on a second. This is saturation equation. صح ولا لا? We ignore the channel modulation. صح ولا لا? Is there any VDS? There is no VDS here. صح ولا لا? Very good. So VDS is way bigger than the overdrive. So that's why we have saturation. So, and the output is equal to VDD minus ID, which is this one, times RD. That's the equation. صح ولا لا? So now, VGS, do you see VGS here? Of course there is VGS. No, in ID, you see? صح ولا لا? So as we increase VGS, because here we are increasing VGS, so increasing VGS, increase ID will decrease what? VDS. Increase. So we decrease what? VDS or V output. صح ولا لا? So that's why we are sliding. We slide until where? Until VDS becomes equal to overdrive. صح ولا لا? Which is this one, VGS minus VT. Boom, we are in the overdrive. As soon as VDS becomes less than the overdrive, we are in triode. Then we are okay. That's it. And in triode, we have a different equation, which is this one. Yes or no? That's it. That's it. And then continue until that's it. Until it can't go beyond when VGS is actually maximum VGS is what? Is VDD, because VDD by definition is the highest voltage in the circuit. Is the power supply. Understand? So this is what we call the VTC graph, the voltage transfer characteristic. Very important to know. Alright? Excellent. So this is how my amplifier behaves. Where I need to be? I need to be in where the amplifier need to be in this region. Where in this region? That's what we are going to study later. Okay, we explained everything here, blah, 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 blah. So here in this region we have the cutoff of the FET. FET is cut off here, yes or no? We just below VT, صح ولا لا? And here is the cutoff of what? Of the amplifier. Why you call it cutoff of the amplifier? Because if VGS is equal to VDD, what happens? It's the maximum, cannot go beyond that. And the current here actually, this is basically the smallest voltage, is very, very, very small there. It's extremely small. So the output is almost equal to 0 here. Okay? Now, these are the observations here. What's the observation we can get from here? So it's the cutoff of the transistor here. We said it. That region here, this region, the cutoff of the FET, and the cutoff of the amplifier happens where VDS and the out, which is the output, is equal to 0 here. It's extremely small. You can consider it 0. It's very, very small. You can calculate that as well. Yeah. So here's the description that is really important for you to take note. Is that as VGS increases, what happens? VDS effectively decreases. So it's kind of what? It's kind of inverter. Increase, decrease. Input increase, output decrease. This is the first one. As VGS increases, ID also increases. Yeah, increases. Increases to the point that, so as ID increases, it pushes VD down. Yes or no? Because the drop of the voltage will be across what? Will be across the resistor, RD. Not across the amplifier, yes or no? So it will push down VD, yes or no? Okay? It will push VD down, 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 until it put it in the ground. Out. Why? Because ID increases. And the output is decreasing actually non-linearly. You can see it's not linear. And G, the gain, which is the slope. You can see the slope. This is the slope. So slope actually also decreases. You can drop, or you can draw the slope of this. It's interestingly that is actually from 0 to 0. In between, it's actually, it increases to the maximum, and then decreases. So the slope actually, if you drop it will be like this. The slope means the output versus the input, or the voltage gain. You'll find this is not here, this is just an extra thing. The slope of the output versus the input, which is the voltage gain, is actually maximum in the between. It's not mentioned there, but it's actually decreasing here. It should be increasing here, but generally it's decreasing there. So we are in this. We are talking about this slope. Okay? But don't worry about this. We'll talk about it in the right time. Alright, let's move on. The question here was, this is two questions here. First question is, how do we define VDS in terms of VGS and saturation? We said we have the equation for VDS, yes or no? VDD minus ID RD. Where the saturation, this is applicable only in this region. Do you understand? And we can write this equation in a different way, but at this point, what is this point? B. This is B. What's this point?
Saturation.
This is the transition between saturation and triode. This is very important because we need to make our amplifier away from this point and away from this point. We know this where is at VT, but do we know this point?
V overdrive.
We don't know. No, I mean VGS here. We want to make VGS. Do we know this point?
It is not equal V overdrive at.
No. Do you know that's this value? What is it? You suggest. You tell me. Maybe you know it. Yeah.
It is not equal to V overdrive because it's transition between saturation and triode.
But hold on. That's VDS. I know this.
Ah, okay. VDS.
صح ولا لا؟ VDS equal to what? But we are talking about VGS. It's good. Maybe you can questions even if you make a mistake. Now you know. صح ولا لا؟ It will stay here. خلاص. You understand? We are talking about VGS here. What is that VGS? Is actually through this equation. VGS at this point B is equal to what? Is equal to VD plus what? Plus overdrive. Yes or no? Very good. The overdrive, how can we get it? The overdrive at this point. How can we get it? So this typically is what? Is the overdrive. So how did we get it here? Let's see. So the overdrive is actually this one, yes or no? This is the overdrive, yes or no? So to get this from this equation, we need to bring this one there and this one there. So it will be VDD minus VDS, yes or no? I need you to find this. How do we find this? Okay. So we need to find this. How on earth we can say that the overdrive in this point is equal to this quantity? If somebody finds it before the end of the class, there is a bonus. 1 point. We'll do it later. Okay. In any case, this is the one. But if you find it now, until or I'll tell you, I'll give you 5 minutes. The first one who finds it will get a bonus. That's it. I will mark my timer here. It's an individual. If he gets it, he will get it, give him. Yeah. It's a competition. So let's see. Okay, let's see. 5 minutes. 5 minutes. And then we take a break too. It's actually very simple.
ترى عادي استعمل التليفون عشان اطلع القوانين.
Sure. Don't look at the slides بس.
What was the formula for ID?
For
ID.
ID.
Okay.
ID. Equal to ID is equal to half Kn B over drive square. How is that? This is the one?
I think so.
Yeah. مش مشكلة. When you hear this ringing, that means it's over. And the grade I will give will be 5 points in the quiz. One of the quiz I will add 5. How is that? So it's like mini quiz this one. Mini bonus quiz. Stuff I know, memory is low and we came from vacation, so use the don't cheat, huh?
No.
Yeah. If you cheat, first of all, it's haram. Second of all, -5. Yeah. If you look anywhere and they can discover that, -5. It's an exam.
Okay. Professor,
Yes.
maybe I got it.
صح. You tell me, Muhammad. Yeah.
Now VGS equals VT plus VDS. Okay.
VT plus
VDS.
VDS. Why VDS? كمل. I mean.
Okay, I'll tell you what the reason for VDS. Because in the graph it shows that it's the point where they both are intersecting. It's VDS and VGS. That's why I.
No. هذه VDS at point B.
Yeah, and VGS is also at the
هذا
same point.
VGS at point B.
Yeah, so
this is the name of the coordinate.
Yeah,
VGS B
that's why.
and VDS. Continue.
Okay, and then so it's VT plus VDS, and we can say that we can take this equation of VDS and put it there.
Well, come. You want to solve?
No, I don't think so.
Did you find the solution or لا?
I have a solution, but
What's the solution?
it's not this. It's not the same thing. It should give us. It will give us the same values, not exactly the same way. And this is ID, and we multiplied it by RD, and the equation of VT was. What is the equation of VT again?
No. If you have a solution, come. If you don't have it, then you are talking loud.
No,
Please. We need other.
I need a paper.
ركز.
خلاص.
How much time do you have?
Right. Who wants to get 5 points?
I'm almost there.
In one of the quiz, والله I will give it on the spot right now.
The square root is.
It's up to you.
Oh.
I don't have any. How many points? How many minutes remaining? Less than a minute. 40 seconds now. How do we define point B? Boundary between saturation and triode. والله يا شباب مش صعبة تمام. لو تشوفوا السولوشن حتقولوا لي والله
ترى السلايدات مو موجودة في
What?
أبقى في 3 قوانين اللي أخذناهم عن الجي ام.
You don't need GM. خلاص راحت. Are we talking about any AC, G or
No.
بس نقدر نضبطهم.
No, very easy, very simple. In the triode, in this boundary, what's the condition here? Is that the overdrive is equal to VDS. صح ولا لا? This is VDS.
Yes.
Class, that's it. This is the overdrive, yes or no? So I have to take this and put it VDS.
Okay.
This is VDS, and this is what? VDS. This is VDS what? Square. This is a second order equation, yes or no? So if you find VDS, it's the same as the overdrive, and that's this one. صح ولا لا? When you solve this equation second order, that VDS is exactly this value. You will find two solutions. Only one of them will be able to find it like this. What's this, by the way? This is delta. Second equation. Determine delta. Delta is equal to what? Second order equation. Delta. Delta is equal. بقى مربع ناقص 4 ألف ج. هذه وأنا صغير ما بتذكرها. بقى مربع وين هي؟ بقى مربع هي العامل نتاع x. المعامل نتاع x هو ايش؟ 1. yes or no؟ 1 تربيع. صح ولا لا؟ ناقص 4 ألف ج. ألف هو البارامتر تاع سكوير. هذا سكوير صح ولا لا؟ 4 هو هذا. 4 مضروب في هالف 2. صح ولا لا؟ 2 وعندك ناقص، فناقص يصبح زائد، اوكي؟ 4 will be 4 k 2 k r دي بلس 2 k r دي مضروبه في ج اللي هي البارامتر تاع هذا اللي هو 1. this case 1. this is delta 2 k n r d. and what is the VDD? yeah VDD مضروب في VDD لأنه هذا هو ال G. so the square root of delta is actually this, which is exactly this.
What about the other minus?
لأنها minus plus صح ولا لا؟ we have two parameters. it is square of delta plus or minus
minus b plus minus square.
plus or minus 2b. b وين؟ b هو البارامتر تاع الاكس. اكس اللي هو هذا. اكس تاع دي لهنا لهنا استنى. في دي سكوير ولهنا في دي. اوكي. بلس اور ماينس 1 or 2 لهنا 1. المهم it's the solution of this quadratic equation. لا ترى ولا. Do you understand? Try to solve it at home and find it like that. Anyway. What's that? VDD? VDD is VDD. Is the circuit. VDD is the
output.
لا it's the power supply VDD. You get it? You got it?
Yeah.
So it's very simple. خلاص? Yeah, that's it. So let's get back to the mode of. So you wasted just 5 points like that. صح ولا لا؟ Simple ولا لا؟ Bilal, did you double check? Solution correct, huh? This quadratic, I know you are tired, you know, that's fine. Okay, fine. Let's go back. So خلاص we solved this. And now we come here. Okay. So this point, this is what we call the operating point, Q or quiescent, we'll talk about it later. So the equation here of the output voltage VDS is equal to this, we know that, خلاص, which is from here. That's it. So the question now is nonlinear behavior there. Why it's nonlinear? You can see. The input is VGS and the output is VDS. VDS is nonlinear to the input, quadratic.
Yes.
And the question, we need linear amplification. Why? Because if it's not linear, that means we cannot really have a sense of amplification. We have to make it square and blah blah. But if it's linear, we have a slope, right? We need linear amplification. We'll talk about it later on too. It's like using a lens. If we amplify, the whole picture will be fine. Now, if we have a lens, some places will be huge, some places will be amplified a little bit, okay? But if everything amplifies the same thing, everything is proportional, okay? We can see the picture without distortion, okay? Okay, good. So, the question is, how can we linearize this? How can we make it linear? We'll get to that in a second. Here, just to define this point, we call it the quiescent point. quiescent point, or we call it also the DC point, or we call it also the bias point. Is the point where I need to make my amplifier working, okay? And I can make it working by fixing this guy, yes or no? Which is the DC VGS. With the DC VGS, I can make this guy to work at this point, okay? And the question is, how will Q help us? How really Q will help us to basically control or to have a linear amplification of this transistor. Okay? Let's look at that. So, this is the trick that we did. So the trick here is to make our AC signal, because VGS is actually, it is a DC VGS, what's this? Plus an AC VGS.
Yes.
صح ولا لا? This is the total, yes or no? So this is what we call the AC. If we make our AC signal small enough, then in that case, if we make it small enough, we can make our AC output big enough. Look, this is the quiescent point. This is where my transistor is working. It's set by the DC VGS. صح ولا لا? Good. Now, if we make our AC signal small enough, if we make it small enough, we can have actually a linear line actually that relates to my output to my input. Here we have linear amplification. That's the trick. And not only that, actually, is actually when I make this small, my output AC actually is going to be big. See? Small change in the input equals a big change in the output. So this is the AC signal at the output, VDS. The DC is there. Alas, the DC is here. I'm not talking about that one. So my output will change like this.
Yes.
Do you understand? And linear, because when we are, it's a very small segment, this will look like a very good line. Do you understand? So instead to take the whole range non-linear, we can take a small range. It will be linearized.
Okay.
What's that? This is the, yeah, exactly. This is the AC input, and this is the AC output. Because the input is my VGS. Remember the circuit, the common source? And our output is actually the VDS, is the AC signal. The DC stays there, we're not interested anymore. Halas? Do you understand?
Yeah.
So this is the trick of linearization. Very simple. It's a joke. Basic. Engineers, they like jokes. Who told you they don't? Very good and simple way. Okay, good. So this is the graphical way. Now we get to the analytical way. Very good, very good, very good. So, in this case, what we do, or what we need to do, is express everything with the right notification. Meaning, VGS, I'll have to write it AC plus, DC plus AC. My DC is not time dependent. It's not time dependent. What is time dependent is my AC.
Yes.
By definition. And that's it. I bring this guy and put it there. Because this is, although here symbol says it's a DC, but this is applied on the DC and on the instantaneous. So I put it there and try to make calculations the same way like we did last time. But what's that? What's this? Did you miss anything in this slide? Let's see. So bias MOSFET with DC voltage defined as. So the first one, so as we said before, we have to find the DC bias. So this is the input, this is the output.
Yeah.
So this is what? The DC analysis. So no. Now when we come to the AC analysis, we have to put everything into perspective. The input now is actually DC plus AC. So we have to put that there and then try to get the AC of VDS, which is gonna be related to the input AC. And that's what we need to, find out. Okay, let's see. condition to make this linearization is that VGS has to be small. صح ولا لا? That's what we said. We'll talk about how small. We talked about small last time. If you remember, there's one slide. We gave the estimation of VGS to, we said that VGS is actually less than 2 overdrives. And you can go back to that slide. But that's fine. We can review that. So, as long as this VGS is small enough, this can be considered as a line. Okay? And as I've told you here, when this goes up, this will go down. See here? So they are inverted. It's like an inverter. Remember, we did also last time, similar circuit. We found that similar. Actually, from the characteristic. When the input is low, the output is high. And then the input goes high, the output goes low. صح ولا لا? Remember the VTC. So this is nothing new about it. We studied it before. So here what we did. So the question, we can calculate the voltage gain. It's actually, this is the voltage gain. This is the symbol, AV. Is actually the variation of the output with respect to the variation of the input. صح ولا لا? My input is actually VGS from the characteristic. And we do this derivation where when VGS is so small and the instantaneous voltage is almost the DC voltage. So small, like the total voltage is the same as the DC, means the AC input is almost zero. فهمنا ولا لا? That's what it means. Very good. So what we do the derivation. Derivation of what? Derivation of VDS, and that's the VGS. Yes or no? That's it. So we put, now we take now VDS, the AC signal. So if we use the AC on one part, we have to use AC here. So if you take the previous equation, so we said, okay, let's take that previous equation, which is this one. If we take now VDS here, then automatically I have to use VGS here. That's it. If I take here VDS here, then automatically I have to do VDS here. So whatever you put here as a signal, it has to be equivalent. So AC, AC, DC, DC, or instantaneous, instantaneous. You understand? Don't mix up. Okay, great. So that's what we did here in this equation. That's what we did. So this equation is the equation of VDS. But the AC VDS, here actually is actually instantaneous. But you can put the instantaneous, you can put also the AC, that's fine. Yeah. We put that there and we do the derivation. Okay? Then when we do the derivation, this is constant, bye-bye. This is constant, get out. The derivation of this with VGS, so 2 will go down. And then the derivation of what's inside is actually 1, because VGS parameter is 1, okay, derivation. And then take whole thing, power 2 minus 1. And we get this. Okay? So this is the derivation of the whole thing. Now 2 cancel with half, so it's gone. Kn stays there. Half minus stays there. Rd also stays there. Then this is, and this derivation of this goes to 0. This is the derivation. Very good. We know this. Kn, the overdrive is what? Gm.
Yes.
صح ولا لا? That's it. Yeah. So it's minus Gm Rd. Huh? This is Kn overdrive. It's actually Gm Rd minus. See now, it's important. We can see that in the next slide. Okay. Where is that? Okay. No, it's the same story, but it's the same slide actually. I have to change it. So the first thing that we find that the gain is negative means it's inverting. Yes. Phase of 180 between the input and output. Yes. Very good. That's number 1. The load resistance is in the gain. Yes. So if you want to increase the gain, increase the resistance, the load resistance. And the conductance parameter is also present, Kn, which is Kn prime, W over L. That's it. We can write it like that, or we can write it minus Gm up. Two terms. Boom. That's it. And you can see that the unit of this is what? The unit of the voltage gain here. This is 1 over Ohm. And this is Ohm. No. There's no unit. Or actually, to be precise, it has a unit which is voltage over voltage. To say this is a voltage gain. Voltage over voltage is equal to 1. Yes, fine.
Yeah.
It's okay. But to specify, to be specific, to be more professional, and to see that this is a voltage gain, it's not current gain or something else. Also, current gain would be ampere over ampere. You understand? But if you write voltage over voltage, the reader will know that this is a voltage gain. You understand? Alhamdulillah. So that's the point. It's just, these comments are important so that as an engineer, we know what we are doing. Do you understand? Good. That's it. I didn't write so far gem RT, but we will see it down the road anyways. Not big deal. Here what we did. We took the gain here and what we did. Okay, from this equation, Kn overdrive. Can we take it from here? This is, if we take Rd out, so this whole thing, we can get it from this equation.
Yes.
صح ولا لا? Make sense?
Yeah.
So you can see. Half overdrive, we take that and put it under ID. It will be Kn overdrive, yes or no?
Yes.
And this is also Gn, by the way.
Yeah.
If you remember that, it's 2ID over V overdrive. We did that today, yes or no?
Yes.
That's what we did. صح ولا لا? Very good. So, here what we want to say by here, what? It actually, we can say that the gain actually is the ratio of the voltage drop across RD. This is another important observation. This parameter. So we know this equation is correct. This is what? This is the voltage drop across RD. And this is what? This is half of the overdrive. That's it. So basically the gain is the voltage across RD divided by half of the overdrive. See? So if we want to increase the voltage gain, what we do? We make the voltage drop half. Or we make the overdrive small. But there's a compromise too. Because if we reduce the overdrive, we also reduce the current. If we reduce the current, we reduce also the voltage drop. So you see? Do you understand what I mean?
Yes.
So they are fighting each other here. Do you understand? Because if we make this small, ID will also get small. So it's, an optimization question here. Okay? Alright? But this is just to let you observe this. Okay. Good. So, okay, let's see. How does this, 538 equation, which one? 538, this one. The last equation we study here. How does that related to physical devices? Okay, let's see. So if we look at the gain, because that's what we don't need to do. We want to maximize the voltage gain in here. So to maximize the voltage gain, we need to maximize the voltage drop. Yes or no?
Yeah.
And we need to minimize the overdrive.
Yes.
So maximize this and minimize this, you get the maximum gain. Yes or no? That's what we were just talking. Yes or no?
Yeah.
So in modern stimulus, the overdrive is usually no less than 0.2 volts. It's not really that big. So this is the typical value of the overdrive. Okay? This means that the maximum achievable gain is approximately 10. Why is that? Because the maximum over voltage drop across RD is actually VDD, yes or no? The whole voltage could be cross that resistance, and VDS would be like 0. صح ولا لا? We are at the very end of the VTC curve. Remember that? So, this maximum value is actually VDD. Okay? And here, the maximum is, or the minimum is actually 0.2 or divided by 2 will be 0.1. So 10 by 0.1 will become about 10. So this is the maximum voltage gain we can get today. Okay? Of VDD. It means here depends on the VDD. The higher VDD, the higher the, because here is basically, this is VDD divided by 0.1, it becomes 10, 10 VDD with minus 10. This is the typical voltage gate. But here is actually the amplifier here Very important here. So, what does it mean? It means that this gain actually does not mean that the output may be 10 times VDD. Not exactly. This is just the AC amplification.
Yes.
Do you understand? Just the AC amplification. It does not say that the output can be 10 times VDD. It tells only that the gain can be 10 times VDD. Okay? Because here there's no unit, remember, there's no voltage in here. Remember, this is a gain, this is not a voltage. This is just the gain. So this is the basically typical range or typical maximum value of the voltage gain. Let's stop here. It was a long day, huh? Okay, have a rest now and see you next week. Next class in the quiz. Prepare. Next week, I know. Thank